Okay. Hi, Keisha. So, to do this, I'm going to assume that you understand part A. And the result of part A was that this is our histogram. And this is a frequency histogram. So it tells us the percentage of the days in this month, right? Of the percentage of days with a certain amount of withdrawals per day, right? So for instance, um, looking here, it looks like just based on this little rectangle here, almost 35%. Because see, that's halfway, so like it would be like 34%. That looks like 34% of the days the ATM machine has about $7,100, because it's in hundreds of dollars, about $7,100 in withdrawals per day. So this would be important. The setup explains that this would be important because as the bank, you have to figure out how much money should you stock in how much money should you stock in the ATMs, right? Because
It's
you
3:45.
thank you, and of course, you,
It's
this
15:45.
thank you. Okay, so like you'll have a different histogram based on the location of the ATM machine and based on the month. So, for instance, if it's back to school, you're probably going to have more days where you need more cash because people are buying a lot. Same thing if it's, December, where people are buying a lot of stuff, you're going to have a lot of days where you have more withdrawals. Okay, so the question we're trying to do for part B is saying if you put $7,850 in the ATM each day, what percent of the days in a month would you expect to run out of cash? Okay, so now the key is that we're putting in 78.50, right, per day. Now, according to this, you will run out if the withdrawals are more than 78.50, right? So looking here, we can see that the days where there are 81, 86, and 91, all these days are going to be above 78.50. And in fact, we can probably, let me see if I have a little, if I have a calculator nearby. You have me a calculator? I believe, so okay, so we just want to be, because we can be even more precise. So if this point here is 76 and this is 81, then this boundary here, to get this boundary, it's going to be 76 plus 81 divided by 2, which is 78.5, right? So these days here, or the days where there are these withdrawals, are the days where that ATM is going to run out of cash, right? And so now the question becomes what percentage of the days correspond to having about 81, 86, or $9,100 withdrawn each day. So here probably the best thing would be to click here to enlarge to be able to see exactly the percentage. Now I'm just looking at this first rectangle, and it looks like it is. So if this line here is 0.15, which would be 15%, then it looks like we're at like maybe 14%. So I put 0.14 here, right? And again, on the, you'll need to click uh, to magnify the graph so that you can actually compute, right? So that you can eyeball it better, because Pearson is very precise. Now let's see for this second bar here with the midpoint of 86. That looks like it's one below. So I'm going to put here 0.05, right? So it looks like this would be 0.04. And then this last one looks like it is somewhere midway. So I would estimate that, I'm just eyeballing it now, 0.07, right? So if this is 0.05 and this is 0.10 and this is 0.15 and this is 0.20, I'm going to say that this bar has a height of about 0.07. So, what percent of the days in a month should you expect to run out of cash? I'm going to say 0.14 plus 0.04 plus 0.07, and that would give me 0.14 plus 0.04 plus 0.07. That's going to give me 0.25, right? And so the answer, so the official correct answer is 23.3%, right? My answer would have been 25%. And again, that's just eyeballing it. If we were to zoom in and literally get out a ruler and measure to see, okay, how close are we, right? Then you can get to that 23.3%. Okay, now what about part C? If you're willing to run out of cash for 10% of the days, how much cash should you put in the ATM each day? Okay, so here the issue is how much cash should I put in if I'm willing to run out 10% of the days? That means that I need to find out where I am hitting 90%, right? So remember we said that this is, we're going to estimate that as 0.07 and this is 0.04, right? So I'm going to have 90% of the days under, let's see here. So adding this together, it looks like this is about 11%, right? Because 0.07 plus 0.04, that's 0.11. So 11%. So my estimate is going to be that at whatever point this is, probably this is where 90%, about 90% of the days will be just fine, right? And then 10% of the days, the ATM is going to run out of money. So, and why am I saying this is a good point? Well, probably, again, I didn't zoom in. Probably this rectangle here plus this rectangle, the heights of those rectangles probably adds up to 10%. So my answer would be, let me use whatever point is here in the middle. How do I get this midpoint? Again, it's going to be 81 plus 86 over 2. So 81 plus 86 divided by 2, that gives me 83.5. Okay, so right here is 83.5. So my answer would be if I stock the ATM with 83, now remember it's in terms of hundreds, so it'd be $83,500. Then about 10% of the days we'll end up running over, not having enough money, right? So this will be when the ATM is going to run out of cash, right? And but 90% of the days will be just fine. Okay, so my answer there would be 83 and a half. And okay, yeah. So it says round to the nearest $100 as needed. So you could round down to 8,300. You could round up to 8,400, and I think both of those are acceptable. Just because Pearson will give you a little bit of an error for these problems where you have to zoom in and measure because you don't have specific numbers. But yeah, so that's the idea behind both of them.